Hello and warm welcome to Agile Talk about clean code. I'm Peter, a software developer at Agile Drop, and in this presentation you will learn a way to write a better and more readable code. We call such code a clean code. Now, this talk is for everyone involved in software development industry, whether you are a developer or a project manager, so let's dive right into it. In the next about 30 minutes, we will quickly glance over this huge topic, and this presentation agenda is split in 4 parts. First, you will learn what is clean code, why even bothering with clean code, and how do developers actually spend time at work. In the second part of the talk, you will learn few clean code examples where we will dive a bit deeper in the if-then-else conditionals, and you will learn few general guidelines for writing clean code. In the third part, you will learn few tips and tricks about clean code, such as clean directory structure and how to introduce clean code in your project. We will also check a few tips about passing code review like a champion. And last, we will also check where to go from here and learn more. Because clean code is a topic that could be discussed over several days of workshops and conferences, and it is a way where you can learn it and improve your code over your entire professional career actually. So, what is clean code? I mean, we are currently living in a very fascinating time of our lives, and does maybe clean code have something to do with cleanliness? Well, the general definition actually differs a little bit from developer to developer and from team to team, but in general, we could sum up few commonalities here. Clean code is nice looking. It literally looks nice visually. This means that it has consistent indentation, consistent code style, and maybe in editors it can be highlighted properly so you can spot and understand code right away. Clean code does what it should. It does one thing particularly well and doesn't do multiple things. Clean code is easy to understand, clean code is easy to adapt, and clean code is easy to maintain. Now this is quite important because 80% of project lifetime involves maintenance. This means either upgrades on server, adjusting dependency versions or something, and if you have a clean code in your project, you will maintain your project easier. This term clean code actually got introduced to the development community by Robert Cecil Martin, Uncle Bob. He's a founder of Agile Manifesto, and he's a very knowledgeable guy, so I would highly recommend you to read his book Clean Code, a handbook of agile software craftsmanship. I found this book really inspiring and it is full of really good advice, so maybe go and buy it and support the author because you will learn very interesting things in there. Now, why bothering with clean code, right? Because your code should aim, hopefully, to be more behind the door on the left side, unlike the code on the right side, where the number of WTFs per minute is bigger. Now the number of WTFs per minute is maybe some sort of a code quality measurement. So the cleaner the code, the lesser the number of WTFs per minute. Yeah. Now, few reasons for clean code, because MEST is expensive and cognitive load is also one of the reasons that clean code can improve. Also, code readability is important, and of course, technical depth becomes an issue. Now, technical depth is this is also known as design depth or code depth, but can be also related to other technical endeavors. This is a concept in software development that reflects the implied cost of additional rework caused by choosing a simpler solution sooner than a better approach that would basically take longer. And mass is expensive. Here, this chart represents cost of change compared of fast and dirty code and clean code. Point is to flatten the curve. Now this is a bit of a joke, but it's very realistic because fast and dirty code is at the beginning of the project cheaper, and basically you can quickly throw something together and it works, but more things that you will do this way on the long run, at some point things will collapse. Either things will become too expensive to maintain and you will need to clean it up a little bit, so to aim to be more on the clean code curve, and or either developers will leave or something. So clean code is at the beginning of the project much more expensive actually, because you need to implement lots of things at the beginning, like automation, testing, code styles, documentation, and things like that that basically present additional effort and cost. Cognitive load, or let's say cognitive overload. Now, in cognitive psychology, cognitive load refers to the used amount of working memory resources. You can try imagining cognitive load as a computer memory. When computer memory gets filled, things start to get written in files on disk and things to become really slow and unresponsive. And something similar basically happens in your brain. Now, this is, of course, a joke from a meme, so don't take this too seriously, but some sort of analogy applies here, because with dirty code, you have additional distractions that will cause you more effort to focus on the code and to understand it, unlike, for example, if you have cleaner code, it will be much easier for you to understand it and to move forward through the application. Now let's check how do developers spend time at work. Well, some of the tasks involve definitely processes that you need to wait to finish before you can continue. Now, project managers won't be so happy about this, but in PHP world, you could say that you are downloading composer packages, or in JavaScript world, you could say you are doing an npm install. Now, when you're actually working on software project, there was an estimation in Uncle Bob's book that ratio between writing and reading code is 1 to 10. So this is quite interesting because only 10% of your time involve writing code, and the rest, 90% of your time, will involve reading code, either code written by someone else or code written by you after a while. So if you have clean code, point is that this 90% of your time on working on software project can become much simpler, much more enjoyable, and much more efficient actually also. So yeah, talking about code is very simple, and we definitely should check out some code examples, what clean code actually is. Yeah. So here we have a first example of nested if sentences. What is happening here? We have multiple conditions, and we are nesting each condition in a separate if sentence, and we're increasing the levels of these conditionals, and something happens if all the conditions pass. Now this code could be actually rewritten much simpler like this, with single if sentence. So here now you will have a single level and all conditions in a single if statement. So unlike this becomes quite a complex on the bigger code and more complex code, unlike, for example, this. Now in the next example, here is a function. This is a PHP code, and here you are uploading file to some path, some destination, And basically, first you check if the path is writable, then you continue. And in the second if, you check if some error happened, and if not, you continue to the third level, and here you check if you are even dealing with an upload. So these are basically also some security checks. And then here you rename your file. So in PHP, files are uploaded through forms, and they are set in a global variable, for example here files, and then you assign a file name on the disk, and here you actually upload the file. Now here point is not actually to focus on the rest of the code, because here this is only for a presentation point of view, so there might be also security issues involved here. So maybe be careful if you will use this code in production, but for understanding clean code using if sentences, it's quite a nice example maybe. And also, yeah, very definitely could be done with more abstraction using today's frameworks and so on. But actually, this function could be rewritten much more understandable like this. Here, you will have multiple, let's call this guard ifs. And on each if, you check basically same things. Now here you've checked this path is writable. In the rewritten function, you check if path is not writable, and you return false immediately, and you prevent further execution of this function. Otherwise, you continue to the next if guard, where you check if some error happened. If so, you immediately return false and prevent further execution. So, unlike this complexity of going into the deeper levels, you just go with if guards, and you return soon, or let's say here return often, and after all the guards are passed, you can, after your code execution passes all guards, if guards, you actually rename the file similar to previous example, and here you upload file to the server, and at the end you return true on success. So maybe, yes, you can see that it depends on case by case, and this is one of the examples like how you can rewrite your code a bit nicer. Now in computer science, there are two hard things actually. Now this is a bit of a funny quote by Phil Carlton, and so one is cache invalidation, which we won't even touch here, and the other one is naming things. Now, try to use meaningful names for variables, functions, and classes, and programming language constructs. And for example, if you have a variable defined like this, like age, now this is not very understandable what this is. You could rename this variable like hours since last visit. This means that you have used intention revealing name in it, and it's much clearer what this variable should mean. Unlike, for example, function get. Now, function get, if you would use more intention revealing name, maybe get what? Get users, because this is more, it reveals its intention. And in web applications, you have controllers. Controller is basically a glue and a place where you process some logic, business logic from models, and you send it to the presentation layer, and you process request and send it as a response to the browser. And you will have basically multiple controllers, so it maybe makes sense to name the controllers based on the context. And for example, you will have block controller if you'll be dealing with block, or admin controller, or news controller, or something like that. Use pronounceable names. Avoid shortening. For example, you ask RLST, you don't even know what this means, you could just name it user list, fetch data, and user controller, and so on. Yeah. Use searchable names. Now here you have a for loop that is executed 42 times. Now, when you are reading this code, you don't actually know what this 42 means. And you could define a constant elsewhere, like defining number of items equals 42. Now you know exactly what 42 is, and you can also search it across your application by this number with these characters. So this is much clearer. Longer names are better than short ones. You could maybe rename some variable more descriptive, like list versus users list, or fetch, function fetch. Fetch what? Fetch users. And use descriptive and unambiguous names. For example, here you have some array of some items, and here are Jane, John, and Joe, and you soon see that these are actually basically could be users. So try to use some more descriptive naming, and instead of some more abstract naming like fetch data, you could use directly descriptive name fetch what? Fetch users, right? So here are few clean code guidelines. Now, less code is always better. It's better to have multiple functions with less code in it than have lesser functions with lots of code in it. For example, let's say 500 lines of code in a function is a lot, and this might be a bit confusing for a beginner because you might think that more code is better, but actually it's not. It's more confusing, and having a function with only few lines of code in it is actually completely normal for a clean code. So we could sum up some sort of rule of thumb here. Let's say 10 to 20 lines of code per function or per method is enough. And more than that, the code becomes dirtier. Less than that, perfectly fine. Try to split code in multiple files. If you have, for example, a single file with thousands lines of code in it, this will very soon become extremely difficult to manage and understand, and you will introduce bugs in your project. So splitting code in multiple files also reduces cognitive load, actually. Now, simplicity is always better than complexity. Don't repeat yourself. Write clean code on a single place and call it on several places in your application. Here, of course, there are also design patterns available to check out and start using them in your software project. For example, more in object-oriented programming languages, so definitely check it out. When writing tests, try encapsulating assertion in a single test. For example, test assertion is like one of the examples is comparing some value in some variable to some expected value, and if they match, the test pass. If not, the test fails. And having multiple assertions in single test quickly makes tests a bit disoriented and difficult to manage. Don't test developers' patience. Make tests execute fast and smooth, and make tests independent. For example, if you have a test that change some database, and the next test depends on that change, these two tests are not independent. Also, testing frameworks provide groupings of tests, declaring tests as dependent on one another and so on, but use these features wisely and with some understanding. Try to make tests repeatable. If some tests depend on the remote connection availability, this is not repeatable test, because you might have an environment where the outside world is locked due to some security or something, and the tests won't pass there. And also, randomness shouldn't affect tests. Here we will check out a quick tip how to organize your files. Now, this might be very simple for people to understand, but actually here things start. This is from your workstation point of view very important, because how do you start working? You start working by creating some a directory somewhere, you create some project, maybe you have some document somewhere, then you can come to an agile drop and you get some document, and you have some music somewhere, and you have some open source contribution somewhere, and some specifications are downloaded somewhere. Now this quickly becomes extreme mess, and you could make this a lot more manageable. For example, I would create some root directory. Let's call it data. You can rename it whatever you want. For example, even your name or something. And with this, I have a single place that I can backup or sync across multiple workstations. And inside data, I create open source directory. These are my hobby projects where I, for example, contribute to some Drupal module, or I open pull requests on GitHub and so on. And I also create TMP directory. TMP is a temporary directory where I just clone some direct repository from somewhere that I need to check, or I create some file that I need to execute for some understanding and testing. I will know that things inside this TMP directory are temporary and will be eventually also cleaned up and removed. It's like some sort of garbage. And now, but I still have things there at least for some time. Now, the most important directory is work. This is where paid projects are done, and the first level inside this directory is a client. These are clients, and inside each client you have projects, multiple projects. Inside the project, I create multiple directories. Also pay attention to one thing here. I intentionally name these directories in case-sensitive way. Some are uppercase, some are lowercase, some are camel-cased, and so on, because different systems also sort these directories differently. And uppercase directories are like scheme-alike directories, and they are more visually, they are standing out a little bit. So that's why I name things like this. And so in project, I create backups directory where I store some data like database, but this doesn't even mean it's production database. It can be development database, some stage database, or some state that I want to store at certain time on a very exact place. Also, directories inside this directory they are chronologically sorted. So first is year, then is month, and then day, and then sequential number. After that, a short description of what the contents are. And with this, these directories are sorted chronologically. Now the next directory I create is dev, so like development, and here is a direct place where I clone Drupal Git repository or some project that I'll be working on, like front-end Git repository or some framework, or where actually the client code lives. Now, fonts directory is just as an example, so this also depends largely on project per project basis, but for designers maybe, you could put fonts in the fonts directory and you have fonts available right away for the project on a specific workstation. You don't need to go to some other place and download it or something. So this is maybe one quick trick. And I also create a WWG directory where I chronologically sort subdirectories in a similar way as in backups directory. Here, I would, for example, I receive specifications of a project, some document. I would put it in a WWG directory under year, month, and date. And with this structure, I know exactly where I need to go, where I need to open some project or some file. So maybe you can think about a little bit, and with this, basically your self or clean organization starts. Yes. Now, how to make room for clean code in projects? I mean, we all have deadlines. We need projects to deliver, we need to finish tasks, and basically how to implement this clean code concept in these projects of yours. First, try to plan this testing phase, technical depth and quality in advance, where you are doing project estimation and you are making milestones and timelines. Also plan this dirty code cleaning. Now, project managers, they will need to basically understand the point of clean code, because clean code should be our common goal. The cleaner the code, better the project maintenance and implementation of new features, and developers are more confident that the new features will actually work without causing new bugs and new issues. And yeah, so basically these are a few tips how to make room for clean code in your project. And of course, maybe if you are dealing with dirty code, you have existing project with a dirty code, you could try maybe eventually, as you are fixing bugs or implementing new features, you could start thinking also about clean code, and to maybe partially start also refactoring code a little bit here and there, and that way you are flattening that curve that we mentioned at the beginning of the talk. So now let's check the code reviews. Code review is one of the common parts of each development. You make some change and you open a pull request on Git server, and code reviewer checks your code, and if code changes are fine, it merges your changes into the branch and deploy this into some environment. Now, in this process, lots of issues can happen, because if you send some messy code that is not understandable, communication issues quickly happen. And in this phase, actually, people also break apart from the team, because beginners should be maybe working on less critical tasks than someone who is more experienced, and they should be working more on more complex tasks that involve the project's entire lifetime. And project managers need to understand this, because it's very important. And here I would give you a few tips how to basically manage these code reviews and how to pass them. Is first, try to position yourself in the other person's point of view. If your code is not exactly understandable, or it's not efficiently created and written something, try reviewing your code before sending into the code review, or let's say into a pull request, so that as little issues might arise. Also try to be constructive, because your code will get criticized, your code will get rejected at some point also, so be prepared for this. And also, if you think that you have written proper code, also stand behind what you have written. Now, as a code reviewer, also try maybe to be more of a teacher than a manager, and try to teach your team member what they should fix using comments, and some constructive comments, some nice language. Don't be rude. When this is quite important, because emotions quickly go through here, and if you are very emotionally distracted at some point by receiving some feedback by your fellow team member, try taking few minutes off and then respond constructively, unlike some ridiculously offensive responses and so on. There are also lots of tools that can make this process a lot easier. I mean, here I won't even list all these tools. Definitely use this. There are, for example, PHPCS, PHP10, DrupalCheck, ESLint, and so on. This is more for PHP world, and there are static analysis, other tools, and you can use automation here. And for example, when you open a pull request, you could basically notify using some hook on the server, and automation software checks your code right away, and a lot less communication issues can happen that way. So also, yes, editor config is definitely one of the tools to check out. Use these tools definitely. And artificial intelligence is also helpful. Some third-party services provide all sorts of things already. Artificial intelligence also in the future will be able to refactor your code, rewrite it to other programming languages, suggest you improvements, and basically to make this process a lot easier. But we're not there, and we also need to do a lot of things manually and to basically create a clean code in the first phase before the refactoring. Now, where to learn more and where to go from here. Here I will just suggest few books. So one is definitely Clean Code by Robert C. Martin. Definitely go buy it and check it out. The next one, Pragmatic Programmer by Andrew Hunt and David Thomas. And the third one, Code Complete by Steve McConnell. On GitHub, there is also freely available Clean Code JavaScript resource, lots of useful advices in there, so maybe go check it out. Also, or for your preferred programming languages, there are numerous ways where you and advise how to make your software cleaner. So I would suggest that you practice this clean code, because maybe you could try taking a bit of a time when you write some code and try to refactor it into the cleaner code from your understanding and your knowledge. And maybe also try practicing on open source projects. This is an ideal place where you meet basically other developers and you communicate changes with them, maybe on some bigger projects, but this is definitely useful practice for you. So yes, every beginner was actually a beginner at the beginning, and to become an expert it takes practice, a lot of practice. And so try to practice it and make it make this process a part of your development. Thank you so much for your attention and checking this video. I hope you have learned something new. Till next time, stay tuned for more from Agile Drop.